All right, guys. So, I mean, the goal of the Intratake is just to get y'all thinking about the fact that sometimes we can't get directly to where we're going. Now, with the ACT science question, the reason that they're talking about this is a lot of it, we can't get straight to the answer. For a good number of the questions, like the ones we saw in lesson 1, we can look directly at that spot in the table, graph, chart, whatever we're looking at and get the answer that we need. Now, there's going to be some other ones that we can't get directly to it. There's one other step that's going to have to take place. And that's really what this is questions getting at. Read charts and graphs, answer ACT questions, find information in the passage, and relate information to given. Now, the first thing is we have this here. This is, I believe, the first page, or kind of looking at it, is our kind of our quick check. So this isn't in your note sheet because, again, all the quick checks are not going to be there. It's just stuff that we've seen before. Now, the first thing we have is A. Well, we have columns because columns are going up and down. Just like in our matrices, we have columns, but we also have what? Rows. Because any chart or any matrix is going to be with columns and rows. We can fix it here in a little bit.
I almost got it. It's gonna work.
Now C, these are kind of our variables, our trials. So it's not in the note sheet. None of the quick checks are going to be in there. We also have the units, so they'll give us a unit amount, and that's somewhat helpful, especially if we're looking at the questions, because if it's asking for a certain unit, so it's looking for minutes, find your answer in minutes, so we're needing to look for a time. If it's asking for distance in miles, okay, we're going to be looking for miles, or some of these here. And every chart is going to have a title. Awesome. Okay.
Well, I can make it look like a real cool. And if I try to
Actually use it.
Yeah, you might just have to beat it up like how I do. Jimmy stuff.
All right, so how would we, looking at these tables, well, the first one, how would we read this? How would we talk about this here? Would we read these two charts differently?
Yeah, no.
Does it matter that this one has more kind of funky verbiage or bigger words or more advanced terminology? Well, no. I mean, the terminology doesn't matter. It's still just a table, yes? This table and this table, we can approach it the same way. They're still just a table. No matter what the information in it contains, they're still just a table. Okay. So for each one of these here, so we're looking at a few passages using techniques called connecting the dots. The purpose of this activity is to help you see exactly how interconnected the questions are with each passage. So in this, you're going to draw lines connecting terms to where they appear in tables and figures. So it's kind of in this part, you're not going to be actually answering the questions. We're not going to actually get an answer. We're just going to be seeing kind of where the connections are. So, 131. And 29. While connecting the dots for this activity. So if we're looking at this here, Like I'm losing my mind. Yeah. Okay. So,
Dadgummit.
for this, if we search, so what we're going to be doing is searching for terms, tables, and graphs. Now, on your note sheet, or kind of the first one that we have, is making that connection, and we have table 1, yes?
Yeah.
Okay. So we can read through this passage, but we're not going to read through it, because any of the passages, just like with the reading, because Ms. Seid said we don't really read the passage itself, we skim it, kind of looking for main key details or key piece of information. So the first thing, looking through that first passage, we want to find the term CO, because that is key in both. So we could draw lines from CO in the sentence to CO in the table. Oh, in fact, I don't have that sitting out. Borrow this and look at it. So I'm going to go on and read this passage. Scientists have found that carbon monoxide gas, CO, is toxic when it exceeds concentrations of 0.1 by volume. In urban areas, automobiles are a significant source of CO. Studies have shown that CO levels in cities are higher during colder weather. A group of students hypothesized that cars emit more CO in colder air temperatures than in warmer air temperatures during the first 18 minutes after they are started. Students then performed 2 experiments to test their hypothesis. So we have experiment 1 and experiment 2 dealing with this here. And again, if we're looking at any of this here, and especially we have 2 tables and we have this chart, yes? So let's look at the first question. So question 1, 2, 3, 4, 5. All 5 of these questions are talking about CO levels, yes? The whole passage is talking about CO. And if we look at the first question here, what percent of CO was present in the exhaust of the 1980s Model A at 7 degrees Celsius after 6 minutes? So which chart are we going to be looking at? Or which table? So we do have table 1 and table 2, yes? They both are talking about CO levels. Both of them have 1980 Model A car, yes? Now table 2, because it also talks about 6 minutes, 7 degrees, negative 7 degrees Celsius, and after 6 minutes, yes? Does table 2 talk about negative 7 degrees? No, so we're looking at table 1. Because percent of CO2 exhaust at negative 7 degrees Celsius. Model A, 1980, after 6 minutes, it would be what? 4.1, which is B. Let's look at number 2. What vehicle had the lowest level of CO present in an exhaust after 18 minutes? So again, we're still looking at table 1, yes? So at 18 minutes, we'll see which one had the lowest percent, which was? Okay, of what year? Oh wait, so the correct answer is H. Question 3, what vehicle had a time period with a higher level of CO2 in the exhaust at 22 degrees Celsius than at 7 degrees Celsius? So, now this one here, we're comparing the 2 tables. We're comparing the 2 graphs, yes? So, but we can also look at the vehicle. So we're looking at 1980 Model AB, 2008 Model AB. And we're looking for a higher amount over that time. And again, so we're just looking through between those 2 to see which one we can have. and it's going to be D. And again, we're just comparing these two tables together.
I'm not gonna lie to you. This time of the day, my brain is fried.
And we can go through connecting these dots, looking from one to the other.
That's all this is about?
Yeah, we're just making those connections from one table to the other. Now, we could draw lines, but they don't suggest it because, again, we're connecting what are the pieces of information that go together. On the science ACT, some of the questions require you to simply to read charts and graphs. For those questions, it's easy to connect the dots because we're connecting one to the other and finding the answer. But many times, the ACT makes this more complicated or confusing. The questions in the next part of this lesson still require the skills of reading charts and graphs, but they require an extra step. You have a layover or an extra connection you have to make. So, and I believe that y'all have this one here in your book on page 32, yes? 32. Now, what would we have to do to first solve this here?
What page are we on? 32?
32, yes. Yeah, so what are we looking for in this here? So we're looking for experiment 2. And what else? Solution per liter. Because these are the two main things we're looking for. And so if we look at this chart, they gave it to us right there. So we're looking for which one has, in experiment 2, which one has the most moles per liter. So which one of these three would we be looking at? First, second, or third? First, because what is this? Moles per liter. So which one has the largest amount? So to C. Okay. Let's look at the next one. Now this one here cannot be answered by just using the table. You also need information from the passage text. A second connection. The question asks you to look for the greatest inhibition. So in table 1, which of the following values corresponds to the bacterium that has the greatest inhibition under alkaline conditions? But the table only describes the zone of inhibition. Without more information, you don't know whether a large zone of inhibition means that it is more or less, means that there's more or less inhibition present. So just having it doesn't tell us enough. Guys, let's go on and shut the Chromebooks. Thank you. Now, the passage does provide the information that we need. So bacterial inhibition by acidic or alkaline environments can affect the efficiency of antimicrobial treatments. The two types of bacteria were measured for their levels of inhibition when acids and alkaline content varied. The stronger the alkaline or acid, the greater the inhibition or bacteria growth. Well, there's our piece of information there. Measurements of the diameter of the zone of inhibition in bacteria cultures regions where there is no bacterial growth were used to determine bacterial growth inhibition levels. So the stronger the alkali or acid, the greater the inhibition. So now that we have that, we can look back at this here. So that provided the information we need. It says inhibition is measured by examining the diameter of the zone of inhibition, which implies the larger the zone, the greater the inhibition. So which one has the largest zone? 10.4. Which means what? Which one is going to be it? So the correct answer is H. And that's it. Questions on this here? So there's two main types of questions on the test. There are direct questions. These questions require you to read the information chart or graph. It's pretty much, that's where the information is. Like the first one we had. We looked straight at the chart, graph, and got it. And indirect questions. These questions require you to interpret a figure, chart, or graph using information found in the passage. They require critical thinking to determine the missing connecting information. So we're going to have to do a little bit more to it. Now, we will eventually get to some where we talk about inferences, where we got to take the data and expand upon it. Or based off the data that we have, what assumptions can we make? Indirect questions can feel disoriented when you first read them because the words you were looking for aren't in the charts and graphs. You can't find what you're looking for. No, you're dealing with an indirect question. And scan the text for the information you need. Some questions require an extra connection, just like some flights require a layover.
I mean, if you guys wouldn't waste our points when I'm not here.
All right, guys, let's look at this next one here. So how would we find the answer for this one here? When comparing simple and fractional distillation, which of the following related percentages is classified as the purest fraction of toluene? So toluene is going to be one of them, yes?
Yes.
So we have, is there any other information they gave us in the question? So when comparing simple and fractional, we have both. Which of the following relative percentages is classified as the purest fraction of toluene?
So we'll only look at the last two, or the last portion, because the things are simply in the fractional. So we split it. So we just look at one side. Where'd you get paragraphs?
Now, do we know what purest means? Did the table tell us what is classified as pure?
No, but the paragraph.
Now, there is a paragraph right below it. In Table 1, simple and fractional distillation are referred to techniques used to separate chemical mixtures by boiling point. Purification of a compound is also achieved during distillation process. During distillation, compounds are separated into different parts called fractions. Relative percentage are calculated to determine the percentage of a given compound in levels of purity in a fraction. The higher percent indicated indicates higher purity. So we're looking at the higher percentage. So between these two, 99.27, which is in the chart, would be the correct answer. Questions on this here? So for this one here, we needed to make a second connection to talk about purity. Yes? Now, I'm going to look back at this just for a minute. Does anybody know how to pronounce that?
I can't even read that phone. Yeah. I got you right here. Cyclo.
Do y'all know what that is?
Or Cyclops.
Cycle of hexane.
A cycle of probably some.
Do y'all know what toluene is?
No.
Cyclohexane and toluene are two chemicals. They're chemical substances, but does it matter what they are to answer this question? No. I mean, most likely, yes. But with the science test, unlike a lot of the other sections, we really don't have to know what this stuff is to be able to answer the question.
Look up the battery.
Look it up on your computer. Wait.
Let's look at this next one here. So,
Say something you want to look at.
Oh yeah, we're on the next question.
That would be.
Smallest DNA.
Wait, smaller? Yeah. Correct?
I'm going to stop here. We're going to stop here for today.
Next
So this here is,
Okay.
this is an activity that we're going to do. I want to make sure that I am fully prepared for this activity because I think with this group we can fully engage into it.